Hello students, welcome to Boundless Maths. Here we make mathematics not just understandable but also enjoyable. In part 1 and part 2 of the trigonometric series, we talked about the definition of the basic trigonometric ratios and the relation between them. Also we looked at the values of these trigonometric ratios for particular angles like 0, 30, 45, 60 and 90 degrees. Now in today's video we are going to have a look at the trigonometric identities and some more interesting relationships between the trigonometric ratios. So let's get started. The first identity is sin square plus cos square equals 1. So if we divide all the terms of this identity by cos square A upon cos square A, and this is 1 upon cos square A, what do we get? Sin by cos is tan, so that means sin square by cos square becomes tan square A. Cos square by cos square gets cancelled, so it becomes 1, and 1 by cos square is sec square A. So that means the second identity is tan square A plus 1 gives you sec square A. Easy? So let's revise. The first identity was sin square A plus cos square A equals 1, and the second one tan square A plus 1 gives you sec square A, right? Now in place of dividing by cos square A, if we divide all these terms by sin square A, then let's see what happens. Sin square A by sin square A makes it 1. Cos square A by sin square A becomes, cos by sin is cot, so it becomes cot square A, and 1 by sin square A is cosec square A. That means the third identity is 1 plus cot square A equals cosec square A. Done? So we have three basic trigonometric identities. First one is sin square A plus cos square A gives you 1. Second is tan square A plus 1 gives you sec square A, and 1 plus cot square A is cosec square A. Right? Now the catch here is how to learn them without making mistakes. Without making mistakes of plus and minus and which term is on which side. So let's start again. The first identity is sin square A plus cos square A gives you 1. Now how to learn the second two identities, second and third one? On the left side we have secant and cosecant, right? On the right side of second and third identity we have 1 plus, 1 plus. Now cosec square A is connected to cot square A. Both have co in the beginning. So cosec square A is connected to cot square A. That means the third identity is cosec square A equals 1 plus cot square A. Learned? Wonderful. What is left out is tan A. So that means the second identity is sec square A equals 1 plus tan square A. So in the second and third identity, secant and cosecant are on the left side, and on the right side we have 1 plus the corresponding ratio, the other ratio, right? So let's pick up all the three identities once again. Sin square A plus cos square A is 1, sec square A plus 1 equals tan square A, cosec square A equals 1 plus cot square A. Wonderful. Now let's look at some more relationships between the trigonometric ratios. Pause this video and in your notebook make a hexagon like this. Now we all know that tan theta equals sin theta by cos theta. Yes? So write here tan theta, write here sin theta, and write here cos theta. Tan theta equals sin theta by cos theta. Done? Now the reciprocal of sin theta is cosec theta. So write here on the diagonal cosec theta. Reciprocal of cos theta is sec theta, and reciprocal of tan theta is cot theta. So now the hexagon is ready to show you the magic. And what is it? We have tan theta equals sin theta by cos theta. So when we go around this hexagon, the first ratio is equal to second ratio divided by third ratio, and this is true for any three of them when you go around. For example, cos theta equals cot theta divided by cosec theta, and cosec theta is sec theta divided by tan theta. So you can check with any of them, all of them are true. Now the next magic is, if you bring the third term to the left side, what do you get? First term multiplied by third term gives you the second term. That means if you pick up any of these ratios, then this is equal to the product of two ratios on the adjacent sides. For example, cos theta is sin theta into cot theta is cos theta into cosec theta is sec theta into cot theta, sec theta is tan theta into cosec theta. Is it amazing? Yes, it is. So this magical hexagon can be used to find the values of different trigonometric ratios. If you are given the value of one of them, or maybe you know the value of two of them, rather than drawing a right angle triangle using Pythagoras theorem, you can directly use these relations and evaluate easily and faster also. Nice? Great. So let's look at some of the practice questions. The first question is, express all trigonometric ratios in terms of cot A. So when you have a question like this, express all the ratios in terms of any one ratio. It can be sine A, it can be cos A, it can be tan A, it can be any of them. So in this question it is cot A. So the first and the easiest thing is, think of the inverse of cot A. What is inverse of cot A? Tan A. So that means tan A can be easily written in terms of cot A as 1 upon cot A. Done? Very easy. Now think of the identity where cot A occurs. That is the third identity. Cosec square A is 1 plus cot square A. That means I can write cosec A as square root of 1 plus cot square A. So now I have cosec A also in terms of cot A. Tan is also done, cosec is also done. Now what is inverse of cosec? Sine. So that means I can just do inverse of this and I get the value of sine A in terms of cot A, which is 1 upon square root of 1 plus cot square A. Done? Sine A is done, cosec is done, tan is done. Now I need to find cos A and sec A. Let's look at the hexagon. How can I find cos A? By multiplying sine and cot. Cos A is sine A multiplied by cot A. Yes? So cos A is sine A multiplied by cot A. I already have sine A in terms of cot A, and if I multiply it by cot A, I get cot A upon square root of 1 plus cot square A. So I have cos A also now in terms of cot A, and I am left out with only secant, sec A. Sec A is inverse of cot A, so that means sec A is square root of 1 plus cot square A upon cot A. So now all the trigonometric ratios are written in terms of cot A. So you begin with the reciprocal of whatever is given to you in the question. Second, you start with the identity where this ratio occurs. So you will be able to find the values of all the trigonometric ratio in terms of the given ratio. Easy? Wonderful. So let's look at the next example. If the angles of a triangle are in the ratio 1:1:2, largest angle being angle C, then find the value of sec A upon cosec B minus tan A upon cot B. Now whenever you are given ratios of any quantities, you start with assuming that the quantities are, in this case, x and 2x, and their sum is equal to 180 degree using the angle sum property. That means 4x is 180, and this gives us a value of x as 45 degree. So this means in the triangle the two angles are 45 degree and 45 degree, and the largest is 90 degree, which is angle C. A and B can even exchange the places because both are same now, right? Now what is the value of sec A? If you remember the table that we learnt in the previous video, we talked about all the values of the trigonometric ratios at 0, 30, 45, 60 and 90. So what is the value of secant of A? If you don't remember the row for secant A, sec is inverse of cos. So what is the value of cos 45? It is 1 by root 2. That means the value of sec 45 degree is root 2. What is the value of cosec 45? B is also 45. Now again, if you don't remember the row for cosec theta, you remember the row for sin theta, the first row, and cosec is inverse of sine. So sin 45 is 1 by root 2, that means cosec 45 degree is square root of 2, right? Tan 45 is very easy, it is equal to 1. Cot 45, because it is inverse of tan, it is again 1. So that means this expression becomes square root 2 by square root 2 minus 1 by 1, and that is 1 minus 1, which comes out to be 0. Easy? Wonderful. So let's move to the next question. The next question is, if the ratio of sine of an angle to its cosine is 8:15, find their values. You need to find the value of sine and cosine when you are given the value of their ratios, which means they are, that is tangent. So you are given sine upon cos, that is tangent. Tangent of the given angle is 8 by 15. Now using tangent, you need to find the value of sine and cos. Yes, definitely you can draw a right angle triangle, find the third side, missing side, and then you can find the value of sine and cos easily, right? But let's look at a different thing. We have learned the identities also, we have learned so many relations between the ratios also. So now let's solve this question using a different approach, and this approach is much faster and easier once you get into the hang of it. So let's see. The identity that uses tan is sec square A equals 1 plus tan square A. Now using this, can you find the value of sec A? Yes. So you can put the value of tan A as 8 by 15. 8 by 15 plus 1, and then square root of it gives you the value of sec A. So this becomes 15 plus 8, which is 23. So that is square root of 23 by 15. Now cos A is inverse of sec A. That means cos A is going to be square root of 15 by 23. Done? Now can you use your magic hexagon and find the value of sine A? What is sine A? Sine A is equal to tan A into cos A. So that means I write the value of tangent, which is 8 by 15, and multiply it by the value of cos A. So this is square root 15 by 23. Now let's simplify this. How do we solve that? 8 by 15. 15 can be written as square root 15 into square root 15, and this is into square root 15 by square root 23. So one of the square root 15 gets cancelled. So that means the value of sine A is 8 upon square root of 15 into 23. So you can just do this multiplication also and write the final answer. So 8 upon square root of 345, right? So in this question we have used a different approach to find the values of the trigonometric ratios. We have not used Pythagoras theorem and right angle triangles. Instead use identities, get into the habit of using identities to find the values, because this is going to be useful in higher grades also. So get used to this method of finding the values of trigonometric ratios. Let's come to the next example now. If tan theta plus cot theta is 2, then find the value of tan theta to the power 20 plus cot theta to the power 20. So now if tan theta plus cot theta is 2, this means you can write this as tan theta plus 1 upon tan theta equals 2. If you take the LCM, it becomes tan²θ plus 1 equals 2 tan theta. Take the LCM and then cross multiply. Bring everything to the left side. So it is tan²θ minus 2 tan theta plus 1 equals 0, right? Now if you consider tan theta as x, this can be written as x square minus 2x plus 1 equals 0, and this is square of x minus 1. So that means x minus 1 is 0 and then x is 1. So this means the value of tan theta here is 1. Tan theta is 1 means theta is 45. Here we need to find out tan theta to the power 20 plus cot theta to the power 20. So tan theta is 1 to the power 20 plus 1 to the power 20 gives you 1 plus 1, so the answer is 2. Easy? Probably the first sight into the question is scary, how to find this, but it's not difficult. So you just get a quadratic equation, solve it, and you get the value of tan theta. So it is 1 plus 1, that gives you 2, right? So let's come to the next question. If 1 plus sin²θ is 3 sin theta cos theta, then find the value of cot theta. Now what is cot theta? Cot theta is cos theta by sin theta, right? Now here on the right side we have 3 sin theta cos theta. If I want to convert this to cot theta, how can I do that? If I have sin theta here and another sin theta here, to cancel this sin theta but this becomes cot theta, I can do that. So what I am going to do is I will divide the entire equation by sin²θ. So what do we get? 1 by sin square becomes cosec²θ. Sin²θ by sin²θ is 1, and 3 sin theta cos theta by sin²θ gives you 3 cot theta. So right side becomes 3 cot theta. Now again bring 3 cot theta to the left side. So it becomes cosec² plus 1 minus 3 cot theta, and this is equal to 0. We have a trigonometric identity between cosec and cot also, right? So that means I can write cosec² as 1 plus cot²θ plus 1 minus 3 cot theta remains the same. So now I get a quadratic equation in cot theta, right? Again if I write cot theta as x, it becomes x square minus 3x plus 2 equals 0. You can factorize this by splitting the middle term, and the two factors will be x minus 1 and x minus 2. So that means the values of x are 1 and 2. This means that the value of cot theta is 1 and 2. So these are the two values of cot theta. Understood? Wonderful. So let's move to the next question. Given that sin A is A upon B, then find the values of cos A and tan A in terms of A and B. Now again we start with the trigonometric identity for cos A and sin A, because sin A is given to you and we need to find out cos A. So cos A is square root of 1 minus sin square A. So that means this is 1 minus a square upon b square and square root of this. So if you take the LCM, it becomes b square minus a square upon b square and square root of the entire thing. So that means the value of cos A is square root of b square minus a square whole upon b. Now you need to find the value of tan A. What is tan A? Tan A is sine upon cos. So it is a upon b divided by square root of b square minus a square upon b. Now again, when you have two fractions in the numerator and denominator, please handle them very carefully. Write them separately like this: numerator divided by denominator. Don't make mistakes here. because this is a very common place where children make mistakes. Write the numerator divided by denominator and treat it like fractions. So first fraction remains as it is, divide changes to multiply, and then you use reciprocal of the denominator or the second fraction. Please don't skip this step and don't make mistakes here. B gets cancelled, so that means the answer is A upon square root of B square minus A square. So this is the value of tan A. Right? So I hope you understood this question. If this video was helpful and you learned something new that you can apply in your trigonometric questions, then please do like the video and subscribe to the channel Boundless Maths. You can download the maths formula card that covers the entire syllabus on just one sheet, all the formulas of the entire syllabus on just one sheet from my website www.boundlessmaths.com. And do subscribe to the channel so that you stay updated for the new videos that get uploaded. Till then, keep learning, keep growing.